At Walden Catalyst, we are super excited about the applications of AI, particularly AI meeting the physical world, and what difference it can potentially make in the way people live their lives in in the future. And with that in mind, we've been spending a lot of time thinking about robotics as a space where potentially we can invest and build some very successful companies. The history of robotics is that early days robots were programmed pretty much to do every movement that they were supposed to do, and that's been the history until the advent of AI, when you could actually use AI to drive robots autonomously. And that's been a huge innovation over the last decade or so. And you can see today way more cars driving around San Francisco, Phoenix, and LA, which really personifies what the innovation is. But we were thinking about how do these technologies really make an impact on the physical world, areas like manufacturing and various verticals where robots can go in. And for this, we started thinking about the basic pieces that are needed to build a very successful company here. And there we believe that companies that can solve a very purpose driven problem and doing it in a very efficient way such that there is multiplicative value proposition for the customer where they benefit tremendously from the automation. You can build very successful companies around an area where many big companies have invested a lot and the technology is relatively mature. With that in mind, we started exploring the space and we came upon ATI, and we became really excited about the company for what it has solved. So today we're going to talk about ATI, and for that I'd like to introduce you to Saurabh Chandra, the CEO and founder of ATI Motors. Saurabh, welcome to our conversation. Thank you for joining. It's a real pleasure to invest and partner with you today.
Thank you so much. Thanks for inviting me.
Thank you. And first question, tell us about ATI. What do you do?
So we make autonomous robots for manufacturers and factories to move material on shop floors, move it from warehousing to the shop, finished goods back to shop floors, move it from one process to another process. So that's what we do in short. Everything from trolleys, bins, pallets, we do across the kind of material movement needs that the factories have.
So, Saurabh, tell me a little bit more about this because people have been talking about robots inside warehouses. People have been talking about during the COVID time, a lot of robots getting implemented. What is so unique about the ATI robots that are deployed in manufacturing side? What is so unique about the environment?
I think there are more robots in videos than in reality, definitely in the manufacturing space. So I think warehousing did take a lot of, I think, and credit to Amazon, which really pushed it, and they had a decade of work behind it so that other people could get inspired from it. But I think manufacturing environments are no two factories are really similar, first of all, right? Warehouses look very same. There's rows of racks, straight lines. Manufacturing is very different. The environment can be very sparse at times, can be very crowded at times, many more people around things, and sometimes outdoor routes. You can have oil spillages, many more exception cases than you would find in typical warehousing. So I think that's something which has really tripped the same kind of robot. So a lot of people thought we'll just take the same warehousing robot and make it work in a factory. Some factories, they worked, but most often they just worked in that tiny warehouse next to the factory rather than on the shop floor. Those are really tough places where in most of the factories we are operating in, we are the first mobile robot successfully performing.
Yeah. And I guess during the COVID, when warehouses got built with robots, they practically built the warehouse and designed designed the warehouse around the robots.
Yeah.
Right. Whereas in manufacturing, sometimes you have facilities that are 10 years old or 20 years old.
50 years
50 years old, and the robots have to work in an existing situation, which I guess is a little bit harder problem to solve.
Absolutely. And a lot of warehousing overall is a much newer discipline, the modern warehousing as we know it compared to manufacturing. So a lot of manufacturing just exists for such a long time. And you may see many times, even when the factories are new, they repurpose the manufacturing site, right? So new factories come up all the time in existing, whereas warehousing is just so much new. And Amazon again kind of set up the template where they built the warehouse around the robot's capability. And I don't think people are able to do that in manufacturing. There's just lot of other automation in manufacturing, and robots are one part of it. So
Right,
you
and,
need to
and
coexist.
even with robots, are pick and place and assembly robots, but not
Not
material
mobile
handling.
robots, absolutely.
Yeah, but what about that problem, the material handling in the manufacturing? How was that problem solved before you come in?
Obviously, you have conveyors, you have overhead rails, and even when there are mobile robots, they were AGVs which were running on like magnetic strips. So I think these were very good for the old generation of factories, which were just making one. I mean, the factories were not as flexible. And I think with time, the big thing which has changed in, say, the last 10 years, and you would have noticed it as a consumer, whatever you were buying is, I mean, used to be like 5 variants and is now 50 variants suddenly in the last 10 years. And that consumer choice is exploding in the factories where you need to make those variants, you need to make small batches, your inventory has to be smaller. And as soon as you make a different variant, then the material flow changes. And how do you do material flow change if it's all running on a magnetic tape, right? So the only solution is to have the mobile robots of the kind that we make.
Autonomously dynamic.
That's right. Dynamic routing, no infrastructure, no fiducials. That's what you need to do this kind of. So your conveyors don't work suddenly. So some people, in fact, think of some of these robots as discrete conveyors. If people come to science, right? They're discrete conveyors who can completely get realigned. And people typically don't want to change. Trolley is also something which is a unique thing to factories. So we started with a trolley mover or a cart mover, which warehouses typically never have carts, right? And discrete manufacturing is full of carts all the time because you have kitting, you have small pieces that need to go, and these carts are really designed purposely for the kind of pieces that need to be made. You don't want to change them. So we were also very particular about designing robots which could fit into existing carts. They've been designed over 10, 20 years. Nobody wants to change the designs just because your robot wants to.
Yeah. So to summarize, far more complex environment in the manufacturing, far more dynamic an environment, many people around in the situation with things lying around, but your robots have to solve all of these problems to even have a chance to be working with your customers. Very good. So one of the things that really excited us about you is even at a young maturity in the company, you have over 30 customers. Many of these are very well-known companies. Of course, customer names are confidential. We won't talk about them, but these are really well-known manufacturers in the automobile vertical or in the consumer packaged goods vertical or in the power electronics vertical. These are the top companies in the world. Uh, and credit to you that you won these customers and your robots are deployed around the world. And how many robots do you have deployed today?
Yeah, it's in hundreds, and will
Hundreds.
not.
So
Yeah.
hundreds of robots deployed successfully and working very, very well with very good uptime. So tell us, why do you win? Why are these really big customers? These are multi-billion dollar successful
15 of them
companies.
Fortune 500.
15 of them Fortune 500. Why did they bet on you? Why do you win?
What we could see is that contrary to a lot of impression, it's been a supply side problem. The manufacturers have been looking for robots that they could put to use, and they are not finding any, right? So when we usually knock on the door and they are ready for it, they give us an opportunity. We usually have the quickest demo, the most friction-free demo of all that they have ever seen, and we quickly get in, right? So
Yeah.
that's, and I can tell you, in the last couple of deals, our customers have had trouble finding competing quotations, right? So there are very few robots which do what we do with the business model we have on subscription and the ease of deployment. I think the factories, we basically tell our customers that you don't need to do much to get these robots in. And factories are very rigid. The customers are very rigid. I mean, manufacturing is known for that discipline, right? You don't want to change anything in that
Copy
factory.
exact, they say.
Exactly. Copy exact, like Intel made famous, right? That is something which they really like, that our robots don't make them change anything in their factories, right? So that's why I think that's been the key to our success so far.
Very good. Tell us a little bit about your competitors. Where do they fail and where do you win?
Exactly this, right? I think a lot of robotics starts with this mindset that now we have this great robot, only if it has all these nice things around it for it to work. And we just go with the opposite mindset. We really think of our robot as a purpose-built self-driving car. I mean, you exactly got it right in the intro, right? I mean, that's exactly who we are. We think of the self-driving car technology applied in a B2B context and purpose-built for this environment, right? So we take advantage of all the things that we do, that we are in an industrial environment, that we are at low speed, and all these things make way in our technology, our algorithms. So we have done all the algorithms ground up, taking advantage of these specific nuances of our context, right? So those things we do, and that's when we just get insane advantage over somebody who thinks they'll just put the standard ROS package and get something running. Then it doesn't take advantage of the context in which you're running the robot.
Very good. Makes a lot of sense. Tell us a little bit about the benefits that your customers get by using the ATI robots. How do they benefit?
I think the first thing, especially in the Western countries, is that there's just no more people to do these things, right? So they're absolutely struggling with manpower shortages. And so this is something which we were surprised when we started. We thought, because we started with India, and we thought, okay, that's a labor surplus market, and we are in other emerging countries too, like say Mexico or Southeast Asia. But the Gen Z across the world does no longer want to do these dull, dirty, dangerous tasks, right? So these are tasks which are repetitive, there's no cognitive involvement, and irrespective of the demographic pressure, which is there in the Western countries, world over, young people no longer want to do this. So the first thing is that they really need help in doing this. And especially when the factory complexity is increasing, as I just mentioned, that is something that is very hard to do with people, right? So to reorient these people continuously, where you have to dynamically repurpose these things, again, very, very difficult. And the other part is just the geopolitics which is happening. There's a lot of back to America. You want to get factories built here. There's just no way that's happening with this, right? So I think it's a combination of all these things. And then the customers are able to see when they add, think of this like a digital material moving endpoint, right? And it becomes part of your overall universe of your MES system, your ERP system. For the first time, you have a spatial system of record, which can now get married to your other systems of record of inventory, of production planning, etc. And the value which comes from all these things getting digitized the second order effects are just massive. But they start because of the first problem, and then they expand because of the second advantage.
Yeah. Let's talk about, it's a really good point. Let's talk about the secondary advantages, because that feels like a really important thing, right? Because traditional investments in ERP, inventory management, for example, it's only as good as the data that goes into the ERP. And a lot of times the data in the ERP system is flawed. They don't know where the material is.
Yeah.
Right? So does ATI help with that, which is because you are predictable in terms of delivery, is the data quality go up for the ERP, and do the customers benefit from that?
Absolutely, especially on the shop floor, we are surprised as to how many factories, and not all of them, but many factories don't really track the data in real time when the material is on the shop floor between processes. And for the first time, because we are carrying them on robots, we can track it in real time and update the ERP in real time. So you have a very good sense of what your work in progress inventory is, which is today an open problem in many of these places. And the other part is that the ERPs typically have logical view of a factory. You're going from location L1, say, to L2, but it doesn't know spatially how are L1 and L2 related to each other, which is, again, as I said, right, for the first time, there is a system which has a spatial understanding of the factory and is able to convert the L1 and L2 into geolocational points within the factory.
Yeah.
And there is immense value in that.
Very good. Can I summarize, which is, looks like there is automation involved, right? Where there used to be manual movement of material, and you solve that. But the ancillary benefit of that, because you're predictable, robots don't take a break, right? They continue to work. And as they do that, the ancillary benefits is you have better data enrichment in the manufacturing side that then helps their existing software to work a lot better. So for example, in a manufacturing line, maybe the line can be more efficient. Maybe the cycle time reduces, right? Maybe the throughput goes up. And the amount of buffer they may have, they don't need to have as much anymore because things are more predictable. Is that the right way to think about it?
Absolutely, yeah. Your work in progress inventory reduces. You have better just in time. You don't have any wrong delivery. Robots will never make a mistake, right? With manual delivery, you will have exceptions
Yeah,
sometime or the other, but robots just do it right all the time.
of course. That's a great segue. Tell us about how reliable are your robots? You have 100 plus robots in their field. How are they doing?
There are factories which will basically stop if the robots don't work, right?
How many kilometers have they run, or how many miles have they run?
So more than 500,000 kilometers put together. We are doing probably more than 50, 60,000 kilometers every month right now. And that number I think will very quickly be more than 100,000 every month. So we are really ramping on the miles that we are doing with absolute zero safety record, and as I said, right every time. Right. So, and we have to be reliable at a fleet level. There's another realization: when in mobile robots, you want fleet reliability and not just a robot reliability. It's not like a fixed robot which is at one place, right? So that's something that we found very insightful, and customers really appreciate that.
Give us some numbers. What is your uptime?
It's in the high 90s.
Excellent, excellent. Thank you. Shifting gears a little bit. So it sounds like you've solved a really, really difficult problem. Your customers find a tremendous amount of value, not only in the automation of movement of material, but the ancillary benefits of being in time and getting production benefits, right? So that is a multiplicative effect that we think about whenever a robot goes into a facility to actually enable something. It's not just replacement of people, right? It is a fundamentally better way to do things and a high amount of efficiency. That's what you've done. You've solved the problem in a very difficult environment that others have not done so yet. Tell us a little bit about what's under the hood. What have you solved that is really hard to do? And why do you have a moat?
I think the first thing we did was that we took a specific problem but went really deep in it. So we did the full stack. We designed the robot from ground up. We do the electronics ourselves. We do the complete software stack ourselves, right? So we don't try to just do some small bit here and there. But amongst the many algorithms that we did, the localization, path planning, etc., specifically seeing the world in 3D, but doing it in real time, in compute which doesn't cost a bomb, right? That's not an easy problem to solve, and I think we did that really well. So making sure that we could run very complex algorithms in terms of their outcome, but make sure that their algorithmic complexity is less in terms of compute complexity, right? So we are able to do a lot of real-time stuff on the robot without using, for example, the highest end of the NVIDIA chipset, but the mid-range of the NVIDIA. So it keeps our power requirements low. The robot overall cost becomes much more affordable, such that we are ROI positive for customers and for ourselves, even in emerging markets, right? So I think those things have really made a difference in terms of trying to solve this problem. And I think from day one, we didn't use the word robot inside ATI for like years. We always thought of it as a self-driving vehicle, right? And I think that mindset made a very, very big difference. We didn't use ROS, as I mentioned earlier, right? We just said, we'll just do what we need. There is no overhead, no baggage. It's a very, very compact, tight system built only for the task that we do.
Great summary. So if I can say it back, system-wide innovation, really taken the pieces that you require to solve the customer's problem, and you've done it in a very efficient way, both in terms of building your own stack, top to bottom, but also purpose-built for the problem at hand, which is really to solve the manufacturing material movement. Is that a good summary?
Absolutely.
So one last question, maybe two last questions. Tell us a little bit about your business model. You referred to a service business model. Talk a little bit about how customers want to pay for your system, right? And then we'll come to the last one.
Of course. So customers want to pay in all ways, and we are ready to take their money in all ways they want to give us. But I think it has really helped our GTM to have offered the subscription model, which in many cases, I think customers have liked it for the flexibility, where they are able to start with low risk. They can start with a few months, figure out that it really works for them, and then commit longer term. I think subscription, more than a financial model, has been a risk mitigation model for many of these large companies. And I think that has been a key insight, that it's not, because I mean, I'm sure the cost of capital of those companies is much lesser than mine, right? So they're not trying to save money by they're basically trying to eliminate risk. It's a fast changing environment. The technology is changing so fast. So what customers are actually solving for is risk by going for subscriptions. But there are customers who want to buy, and we are very open to that too. But I think it was a key insight for us that we are not trying to save customers capex. I mean, we're working with Fortune 500 and we are a startup, right? So we don't have any illusions about that.
Can I summarize? Which is like low friction for the customers to try you.
That's right.
And then when they really love you, they buy or they subscribe to
For
a bunch
longer
of
periods.
robots,
That's right.
and that really helps them.
Absolutely.
What is the maximum number of robots you have in a facility
In
today?
So we have one, for example, automotive tier 1, which has around 15 robots
15
right
robots
now
running.
in a single factory. Yeah,
15 robots running in one factory 24/7.
absolutely.
Very impressive.
Yeah.
One last question, Saurabh. For entrepreneurs excited about building robotics company, what is your advice to them? How to think about building a successful robotics company?
I think there's more than one way to do it. So I don't think we know like some gospel truth or anything like that. But I can tell what worked for us, and if it's valuable for somebody, it's to really be customer focused. It's to understand the problem deeply and then figure out. A lot of times I've seen it's the other way around, a solution looking for a problem. Although we did build a solution before we narrowed down to factories, but our problem space was reasonably well constrained. We had this thing about being rugged, B2B, material movement, right? So I think making sure that your tech stack is very aware of the problem that is being solved. A lot of people are thinking that there will be some very general purpose robot which will do everything. Maybe a time will come for that, but I don't think that time is now. I think right now, purpose-built robots will outperform robots which hope to do everything.
Great advice. Thank you, Saurabh. It's such a pleasure to work with you. Great conversation today, and great to invest and build a tea together with you. Looking forward to the collaboration with you. Thanks for joining me in the conversation today.
Yeah, thank you so much. Thanks for backing us.